Hello, Algebra 2. Here's our agenda for Tuesday, April 13th. We're going to do notes number 35, and there will be homework today, assignment number 36, 11 problems on the last slide of this presentation. So today, the essential question is how are expressions with negative and positive rational exponents simplified? And at the end of this lesson, you should be able to say that you can use the rules of exponents to simplify expressions that have rational exponents. Okay, so a bit of review here. So this is an image, partial image, of what we did yesterday. So this was from yesterday's notes. So I just want to review really quickly. I don't want you to write anything right now. So yesterday we went over the rule for like product of powers, a to the m times a to the n. What do you do with the exponents? You add them. Or likewise, over on the right here, a to the m over a to the n. Then you would go ahead and subtract a to the m minus n. So today, we're just changing this to rational numbers. Rational numbers are fractions. So watch what happens when I move this. Instead of being a to the m and a to the n, it's going to change to fractions. So a to the m over n times a to the p over q. So we're just changing the exponents to fractions. And in this case, what would you do with those fractions? And right here you can see that when you have fractions, you're just going to go ahead and add those. Okay, and same with over here. I'm going to move this. So when you have a base that's the same, a over a, what do you do with the exponents? Well, you would subtract them in this case, even if they are just fractions up here. So you would write the base once and then subtract the fractions. So this sheet is essentially exactly the same as this sheet. There's no difference, except we have fractions now, okay? So you don't have to go ahead and recopy this. You can just, they're the same rules. It's just going to change to fractions. Okay, so let's do some practice. So this is where your notes are going to start for notes 35. If you can take a minute to write down these 3 examples at the top. So write down these 3 examples. I'll wait for just a second. Hit pause on the machine, on the video. Okay, so for the first one, the rule is when you have a multiply dot, you have the multiply dot here, you're going to add your fractions. So the base is the same, a and a. Here we have 9 and 9. We just write the a once, so we write the 9 once. You do not multiply the 9s. Leave the base alone, but you do add the fractions. So it's going to be 1/4 plus 2/3. So now we actually have to do that math. We need to make sure that we have common denominators in order to add fractions. So off to the side, 1/4 needs to change to a fraction over 12. 4 times 3 is 12, so I multiply the top by 3. So I'm going to use 9 to the 3/12 plus, now I have to do the same for 2/3. 2/3 needs to change to a fraction over 12, so I need to multiply by 4. So that would be 8/12. And now I can get my final answer. So the base stays the same, 9. 3/12 plus 8/12 is 11/12. And that would be the final answer. Okay. All right, the problem on number 2 is the same. We have a multiply dot. So when you have that multiply dot, the base is the same, x. So I'm going to write the x once. I'm going to change colors here. and then I'm going to add the fractions. So 1/7 plus a -4/7 is the same as -4/7. The denominators are the same. So what is 1/7 minus 4/7? X to the -3/7. Now I have to deal with the negative exponent. So here's the rule for the negatives. What happens when you have a negative exponent? It dives down, we went over that yesterday, into the denominator, and the exponent, the m over n, becomes positive. So I'm going to need to dive this down. So I'm going to put equals, put a 1 on the top. That'll be x to the +3/7. So as soon as we move it down to the denominator, the exponent becomes positive. So there's our final answer. So there was both rules there. Okay, if we look at the next problem on example 3, remember 25 has a hidden exponent of 1. So if you don't see an exponent visually, you have to fill in the hidden 1. So this problem is just asking you, because it says leave no negative exponents in the final answer, it just is asking you to deal with this a to the -4/9. All right, everything else is fine. So what happens when it's negative? It dives down into a denominator so that a to the -4/9 is going to get moved into the denominator. So I'm going to draw a fraction bar. 25 stays put. B to the 1/8 stays put. But that a to the -4/9 needs to dive down. And once it does, you make the exponent positive. And that's the final answer. So this problem is only asking you to deal with the negative exponent right here on the A. Okay, we're going to move on to the next set. If you can write down those next 3 examples, hit pause on the video, please. Okay, so on the next problem, the rule is right here that we're going to use. And remember, what do you do when you have a parenthesis in between the exponents? Then you multiply the exponents. So this little parenthesis should indicate that you're multiplying the exponents. So this will become y to the 3/7 times 2/5. When you multiply fractions, you go straight across, tops and bottoms. 3 times 2 is 6. 7 times 5 is 35. Check to see if you can reduce. You cannot, so you're done. So the final answer here is y to the 6/35. You're just multiplying the exponents. Okay, so you can deal with this fraction separately. So we have b squared to the 4/5. So I distributed here, and then you must distribute to the bottom over c to the 4/5. So you have to distribute to the top and the bottom. So that's this rule right down here. Distribute to the top and to the bottom. And now on the top, right here, we're back to this rule where we go ahead and we multiply. So we need to multiply for the b. So it's 2 over 1 times 4 over 5. So that would be 8 over 5. There's no changes on the c on the bottom, just the b on the top. So b to the 8/5 over c to the 4/5. Now you cannot do anything more because your bases are different. One base is a b, one base is a c. So that's it. We can't do anything more. That's your final answer. Okay, the next one, we're just going to distribute, distribute. Now remember, each time that we're going to distribute, we're going to be multiplying the exponents because of this parenthesis. Okay, so you can think of this as having a parenthesis on each one. So 4/5 times 1/4, 4/5 times 2/9, and then the C, you'll just get the 4/5. Okay, so A to the 1/4 times 4/5. B to the 2/9 times 4/5. And then C just to the 4/5. So we have to do that multiply. And remember, when you multiply your fractions, you just go straight across tops and bottoms, right? So this one will be A, 1 times 4 on the top is 4. 4 times 5 on the bottom is 20. And we need to reduce that. So 4/20. You can divide out 4s. That would give you a 1 and a 5. So our final answer is A to the 1/5. Okay, the next one, B. 2 times 4 on the top is 8. 9 times 5 on the bottom is 45. 8 and 45 cannot be reduced, so that's final answer for B. And then the C to the 4/5 just comes down. And then I'm just going to highlight the final answer here. Couldn't draw a box, that was too close. Okay, there you go. So remember on this one, you're multiplying because you have to think of each of these having its own parenthesis, right? And so when we multiply, when we distribute, we need to multiply by the fraction that's already there. Okay? Alrighty. So now there's going to be something a little bit different on the next slide, so please pay attention for just a minute. So this is a little bit new. Okay, so on the next slide is today's homework assignment, and after that, this video is going to continue. After the homework is the warm-up review for students that were absent today on Tuesday. So here's your homework. So make sure you hit pause on here and do the homework problems. Now, if you were absent on Tuesday, then I'm going to go over right now what we did in class at the beginning. We did a bit of a warm-up and review. Okay? All right, so make sure you get the homework done and upload that to the digital workbook. If you were absent on Tuesday, please make sure that you listen to the rest of this video. Okay, so we went ahead and we just talked about the review for the exponents. We went over to make sure that a to the 0, anything to 0 is 1. And we also, if you have just a plain a, that there's always a hidden 1, and that's important. These are the two most common exponent rules that students have difficulty with. It's the negative exponent, and negative exponents are just a movement. So a to the -5, you're just moving or diving that down into a denominator, and you put 1 in the numerator. And when you do a movement like that, you make the exponent positive in the final answer. So here a to the m is positive. When you have two negative exponents, then it's just a movement. So a to the -m dives down to the denominator and becomes a positive m. B to the -n moves up and becomes a positive n. Okay? All right, and then we did a warm-up. So on this one, we wanted to make sure that we filled in a hidden 1. And the rule, when your base is the same, y, and y, and you have a multiply dot in between those terms, then you just add the exponent. So it's 5 plus 8 plus 1. So the answer here is 14. Y to the 14. And then this one, again, the base is the same, m and m. So you write the m, and it's -9 plus 7. So that would be m to the -2. Now this is a negative exponent. Your final answers must contain only positive exponents, so you have another step to do. You need to dive this down into the denominator over 1. And the exponent of 2 changes to a positive 2 once you make that movement. And then this one we went ahead and we talked about if your base is the same, then you just subtract your exponents. So this would be 12, 16 minus 5 is 11. And then this one we just talked about going ahead and distributing. And here again, you want to make sure that you remember that this parenthesis is a reminder to you that this is the time that you go ahead and multiply the exponents. Okay? And don't forget that the 8 gets the 5 because there's a hidden 1 there. 1 times 5 is 5. And then a to the 6th to the 5th is a to the 30th because you're multiplying. B to the 3rd to the 5th is b to the 15th because you're multiplying the exponents. Up here is where we added the exponents. Okay, and then we also reviewed fractions. So if your denominator is the same when you add or subtract, that's easy. You just keep the same denominator, so 7, 7, 7, and you just add the top. 3 plus 2 is 5. But when your denominator is different and you're adding or subtracting, you have to have the same denominator. So you want to go ahead and make the 7 into a 14. So you would do that by multiplying by 2. How does 7 change to 14? You multiply by 2, so this would become 4 over 14. You then ignore that, and this just becomes 3 14ths plus 4 14ths, which is 7 14ths. And then you need to recognize here that you can reduce. This would be 1/2 because you are dividing out 7s. You can divide a 7, it would be a 1. Divide a 7, there'd be only a 2 left, right? Okay, and then we just did the next one. On subtract as well, you have to have the same denominator, so you need to change the 2/5 into a 40. So 5 times what is 40? 8. 5 times 8 is 40. So on the top, we're going to do 2 times 8. So this would become 16 over 40. You then ignore the fraction here. 16 40ths minus 1 40th is 15 40ths. And then you need to reduce. You can divide out 5s, right? Because this is 5 times 3. This is 5 times 8. So we can divide out 5s, and this would be 3/8. And then the last one is yay for multiplication. When you multiply fractions, you just go straight across tops and bottoms. 6 over 20. Check to see if you can reduce. You can. This is 3 times 2. This is 10 times 2. You can divide out the 2's, and this would be 3/10. Okay, and then the last thing we did, that's it. Okay, so that's what we did Tuesday in class. Please try and come to class every single day because we will be doing warm-ups that will be helping you, okay? Have a great day, you guys.